Hello, how's everyone doing? Hey Humpty Dumpty, what's going on? All right, we still have to finish up the Steac C sample, so I figured we could, no longer do any of the AI stuff because it's kind of boring, and we could actually do some real reverse engineering. So that's what I'm going to do today. We still have some obfuscation that I need to deal with. I had written some solutions for that off stream, but I figured we could do that on stream to make it more interesting. We had written some automation to handle the string decryption functionality. So just kind of show you what that looks like in our little README here. But basically all this code is going to do is I'll pull up the string decryption function here. And this is actually more than just imports, but I'll show you this in a sec. So just to kind of go over what we found last time, there was just this function that was doing some string decryption at the beginning in the start function here, which is our entry point, our address of entry point for the portable executable. Yeah, so we had this initial function that's called, as you can see here, there's a whole bunch of calls to this MW decrypt string function. And if we looked at the implementation for that, it's just a simple XOR cipher that takes a first argument in which that's effectively the key. And then the first argument, I believe, the second argument is the key, and the first argument is the ciphertext. And then it's just a really basic XOR loop where it iterates over the second argument being the key for the length of the key using modulus. So this just ensures that it doesn't run over the length of the key, and then it XORs that with each byte of the ciphertext, and then stores the result in the local alloc result here. So this is just creating a buffer in memory for the size of string length, which is the third argument. And if we go back here, then it just has basically a length, key, and pointer to the ciphertext in memory there, which is all global variables. So literally all our automation was doing here was taking, let me open a little snippet here. I just had to recreate this because it was on my other Bidget instance that wasn't in this VM, but I want to start using this VM for everything. So all this is doing is it's going to go through our target function. So it's resolving this by name. So in Binary Ninja, you can call this bv.getSymbol by raw name. And then we're resolving the address of MW decrypt string. And then it's getting all the callers to that target function, which is effectively these locations here. And then we're just extracting the parameters for every call site, and then just using this little XOR transform in order to decrypt each string with a given key in plain text and length. So pretty straightforward. We did actually, I don't believe this decrypted the other call site here, so I might have to do that. But once we decrypted all these strings are effectively being assigned to these globals, and then these globals are being used elsewhere throughout the binary. So I'm going to write some automation to effectively rename these globals to the contents of the decrypted string so that we can easily reference it throughout the binary. Another thing we could do, I know we can't actually do that, but if there was actually data of the size of the decrypted data, then we could overwrite it with the decrypted string. But in this case, it's just going to be a pointer in memory that's allocated using that local alloc. Yeah, so I'll rename all these globals. We'll write some automation to do that. And then there's actually another resolution function that resolves get proc address. And then that also does some function resolution and then assigns those to a global. Lopsec, sorry if you already shared. I joined a little late. Do you have the hash? Yes, I do. Lopsec. But this is on UnpackMe, so I can give you this. Lopsec. I don't know if you have an UnpackMe account, but that's probably the easiest thing to do right now. Another thing we have to do is just decrypt the strings. I think there's another function that's resolving these. So if I highlight the MW decrypt string function here, I can get the cross references in this pane. And then if I scroll down here, we can see that the first set is in this MW decrypt import setting strings, which isn't all imports. So I can just say strings 1. And then if I minimize this little tree here, I can see there's another function that has a lot of references to these decryption strings that we want to resolve as well. So kind of nice little Binary Ninja UI elements. And then let's just call this mdecrypt strings 2. And then we're just gonna have to adjust our little script to decrypt this one too. So let's do that. So MW decrypt string 2. Let's run this. We had an exception here, so let's see what's going on. Object is no attribute address. All right, let's try this in our little REPL here. See why this isn't correct. So, oh, it's because I don't know how to spell strings. Okay, cool. It's easy. Yeah, cool. Thanks, France. MW decrypt strings 2. Yeah, that looks good. And then the key here, list index out of range, $params. Okay, so let's see what it's being, we'll do some print debugging here. Okay, we already have the callers, and the print line is the key on line 23. So let's just do this up here. Let's see what it's trying to resolve to see what the problem is. Key is not defined. Doing that. Okay, and this is trying to resolve this one. Oh, I see. Okay. So we actually don't want to do, sorry, I just kind of forgot how the script worked. We want to do MW decrypt string instead. Okay, and it's currently running. Okay, so it's decrypting all those locations now. So that should be, that should add comments to this section as well, hopefully. I don't know why it wasn't before. Again, if we look through these decrypted strings, we already have things like the C2 and the panel path and juicy stuff. So this is why we want to put up that upfront effort into decrypting the strings in order to be able to resolve them accordingly. And then it really helps out the reverse engineering effort, obviously, because it has key information for what we need out of the binary. And there's also a whole bunch more functions that are dynamically resolved here. Okay, so the next thing that we want to do is basically adjust this isCall function, I believe, in order to, I guess we can do it down here. Sorry, this is already answered, but is there a particular reason to not use directly bb.getCode refs to get all the call locations? I might have get callers. Sorry, I wrote this last time we were looking at this binary, which is like a month ago. So I'm just trying to remember why I chose to do it that way. Get code refs. Yeah, I think that's also probably a better way to do that. Magus. But I think at the time I was just using the target function to get the callers. But if I was to do what you said, which is probably better, bb get code refs to our, oh yeah, I remember now. I think it was primarily because, and this is gonna be a generator object, right? I think it was primarily because of the nesting, but I still think that would work. So not entirely sure why I didn't do it that way, to be honest. But let's continue here. So the next thing I want to do, the trick is to not update Chrome. I think it also worked. Didn't it just work with the string? Or am I tripping? Oh no, okay, that didn't actually work. But yeah, so we would resolve the the target func, and then it would be like bb.get code refs target func.start, right? Why doesn't it have a start address? Oh, because it's a function symbol. What am I doing? Oh, dot address, right? For the symbol address. Anyways, I understand what you're saying. Address. So this would be this would basically be like what you were talking about. I added tags into the MCP server for Malware Bazaar. Josh, it is pretty helpful. Oh, nice. Okay. Still needs work. Yeah, I definitely want to check out the MCP server. I kind of want to take a break from the AI stuff just because, you know, it was kind of all we did last time. But definitely want to do some more work in that respect because I think it's really helpful. Okay, so let's get back to this. So if we do, the only thing I don't like about this window manager that I usually like on OS X is I can actually just leave the snippets window open and then bring that up, but that's okay. Okay, so once we acquire all the call locations and their respective parameters, we essentially want to get the destination being that global and then rename that to the resolved string, or at least like a version of that resolved string. Some of them are obviously not going to be valid variable names in Binja. So say we do like this line, current IL instruction just gives us the current like high level intermediate language representation, not pseudo-C, and then destination, and then that's going to be the address we want. So say we go back to our get callers, caller.params. Yeah, so I think the reason I did it this way was because I needed to get the actual call instance rather than the high level IL instruction. Okay, so yeah, so it's going to be the call site, and then it's going to be the caller, get callers. I just can't remember what, because we actually might want to return both the call instructions. Because, okay, so essentially what this is doing is it's traversing the whole high-level intermediate language instructions. So it's just basically getting this call location from their decompilation recursively using this traverse call here, and then there's a callback and a whole bunch of fancy stuff. But basically all that's doing is it's making sure that there's a call instruction and returning those. But I need that whole call instruction now in order to get the global that's being assigned in order for me to rename it. So the really cool thing about the binge API is, like, say I'm within a sub HLIL object. So I'm kind of emulating that in this instance by getting the first operand, which makes up a high-level IL call. And then I just do like instruction, then it'll actually give me the whole HLIL object that sub object is within, if that makes sense. So it's kind of like, this is, if anybody's done any Hexarrays work, it's like substantially different. So then the binge API was really nice. Okay, so if I go back here to our caller address, we want caller.instruction.dest, and then we want the destination, which will be, okay, let's just emulate this whole thing again, instruction.dest. I keep selecting the comments by accident. .dest, and then we want the high-level IL dereference. Basically, we just want to define a global symbol at that location. So I'll show you what that looks like. So this will be the global address. So if I double click here, then, oh no, that's the dest.constant maybe. Well, let me grab the actual object so I can autocomplete on it. I'm messing up the REPL. Dest, and then okay, we need to get the const pointer first. Okay, so this is just, again, accessing kind of the sub objects of this. So const pointer and then constant. So this is the address of the global. And then, so that's what we want to rename. And then I just want to see if I can do that from this object. I don't think I can. No, it's just going to be a pointer. So it's not the actual object itself, but we can get around that by basically just defining, and if anybody knows a better way to do this, who's more familiar with the binge API, we can basically just define a user symbol at that location. So it kind of looks like this. Let's make another function, set rename global, and then we'll just do address and name. And then I just got this from some notes because this took me a little bit to fully get, but this try block because we want to make sure it's actually working. And then this will just be BV, so define user symbol, and then the data symbol is the type of symbol being defined, I believe. And then we can get rid of this. And then the global assignment operands constant is going to be, I guess we just want to pass the address here. So we want this to be the name. So basically all it's doing is it's creating a data symbol at a given address with a given name. And then in order to get the destination address, I just need to do the a.operands 0. So it'll be destination dot, this is pretty ugly, but there's definitely better ways to do this, but so it'll be this operand 0 dot constant, operand 0 constant, that'll be our destination address. And then basically we want to rename it the decrypted XOR plain text, but we're probably going to need some like function to make those without spaces and stuff. It really depends on the decrypted strings here, but maybe we can just write like a quick regex to swap out any unsafe characters, and then we can probably just test it to see if because basically we're going to be renaming these globals as those decrypted strings, so we just can't use some like the backslash and stuff, I'm pretty sure. So why don't we just do a quick regex? So we'll do import re and then swap unsafe. It's not really unsafe, but name, and then we're going to do re.sub, and then we're going to do a character set, and this is going to be a regex. So the character set being that we probably don't want like backslashes or forward slashes. I don't think there is, but underscores are okay. Let's see what else there. Got forward slashes, colons maybe. I think dots are fine. What are the other characters we don't want? Let's look at the other function. It is not going to be, it's coming. Okay, I think that should be good. Forward slashes percentage, that should be okay. We probably don't want percentage. And then we want to swap those out just for like underscores in the variable names. And then name, and this is going to be S name for safe name. And then let's just return S name. Okay, so we're going to have the decrypted plain text, and then we're going to have the swap name, or swap unsafe rather, PT, and then var name. And then let's just rename those variables on the fly. So we'll do rename global, and we'll get the address being the one that we just did. So destination, adder, and then our var name. And then let's just say, let's print out a little log for us, say renaming, and then we'll do address to X to name. And then that should be good. Let's see if I messed anything. But yeah, we only want to do the first character, or the first caller here. So let's break on this. Let's see if my code works. Cannot use a string pattern. So let's just decode the XOR decrypted plain text. So we'll just do XOR decode PT. And we'll just decode this before we pass it to our function here. So basically what's happening is the XOR encode transform is just returning the result in bytes, which just makes sense because you're obviously not going to have an XOR without bytes most of the time, or sorry, without ASCII most of the time. Or you're going to be XORing everything, including strings most of the time is what I'm trying to say. Is your day? 3301. Thanks for the raid. How's everybody doing? That's the second time you raided us in like 5 days. Let's see what's wrong now. Hurry sub. Hold on. This windowing system is not great. Cannot use a string. Oh, no, that worked now. Oh, and I forgot the format string, so let's do that. Okay, before I do that, everybody go follow 0day3301. 0day3301, what were you working on today? Unless you had to go right away. That's okay. Okay, so for the raiders, basically I'm working on writing some scripting just to clean up some strings within this binary ninja database for some malware reverse engineering. And I'm just automatically renaming some variables with this code here to make it basically decrypting strings and then renaming the variables that those strings are for to those strings is what I'm doing right now. Okay, so that should be format. But yeah, thanks all for hanging out. Hello. Yes, had no nerves today to do a box on What do you mean you had no nerves? You weren't able to finish it? So, okay, so now that's working. So now let's rename all the globals. We'll do the next one here. So I'll get rid of this break. Are you guys just hanging out and chatting? Is that what you mean? You had no nerves? All right, we got an exception here. Let's see. Buggy connection, reset the machine. Oh no, that sucks. It's actually super windy here, so I was scared that the power was gonna go out, but so far so good. So if it suddenly drops, that's why. All right, what's the problem here? Yeah, my door in this room is closed and I have no windows open, and there's still like, for some reason, vacuum pressure in my house somewhere that's like pulling on the door, which I thought was pretty wild. Caller instruction, dest operand 0 constant. Okay, what's the instruction that it's failing? Okay, so, it's because it's not a global. There's a local variable. Okay, we can probably fix those ourselves. So why don't, because I don't really want to have to implement the local variable renaming for now. We can just fix up the few of those that are there. So maybe we can just wrap this in a try block. So we'll do like, say something like caller.instruction.dest if is instance. So if the destination object type is, let's see, current IL instruction.dest high level deref is this, we'll process the object. I'm just going to skip this line. Basically just ensuring that the destination variable is the type that we're expecting, which is a global. Okay, so this is basically renaming all the globals right now. Probably wanted to swap out the spaces. Okay, so all those globals are renamed now. Look at all these nice named globals now. Okay, so the next thing I want to do is just handle this other scenario, which was the get proc address. And basically, I want to do the same thing, but get the name of the symbol and then rename it here. So not too bad, hopefully. I think we can just use the tokens for that. So let's write a new script. We'll say rename assign global or something. Okay, and then we want to do something like current IL instruction. And then basically we just want to do the same thing, but So let me get that rename global again. And then we're just going to do, so there's going to be some sub instructions, but I think I can just do the same. Yeah, nice. Okay, this should be pretty easy, hopefully. So this is probably load library, I assume. Yeah. Okay, so just to kind of explain what I'm doing. So how this malware works is it'll decrypt all those strings that we were looking at earlier. Then it'll use those strings to dynamically resolve imports in memory that it's going to use at runtime. So a lot of, basically like all Windows malware does this. It is for bypassing security controls and basically making, sorry, my firewall, basically making reverse engineering more difficult by having all of the runtime functions that it's going to be using for its functionality resolved dynamically. And then usually, not all the time, but more often than not, it'll assign them to global variables or a global function table that it then references throughout its execution in order for it to leverage those imported functions from Microsoft Windows. So the reason that this is significant is because once we have all of these functions resolved, then we know all of the Microsoft Windows APIs that the malware is going to be using, and it makes our job like a million times easier just because a ton of malware, not that often anymore with more modern languages like Rust and Go that just basically like ship a giant binary, but most malware wants to stay as small as possible, and because of that it does what's called dynamic function resolution, which is what we're looking at. And so it leverages Microsoft Windows APIs rather than shipping statically linked code. So that's what this is doing for those of you who are not super familiar with malware analysis. So what it's doing here is it's resolving this function called load library A. And load library A can be used to load a dynamic link library or a DLL on Windows into memory. And then they can call what's called get proc address, which is another Microsoft Windows function that's commonly called by malware. And then this just basically resolves a given function from a DLL or library that's loaded into memory. So that's all it's doing here is basically getting L string cat A from kernel 32, and then get proc address returns the resolved function in memory for a given address, or it gets the address of that function in memory rather, and then it's assigning it to a global variable. So basically all I'm doing right now is we XORed those strings and then assigned those decrypted string names to these globals. And then so now I want to assign those resolved function API names to these other globals. So basically it's just like two levels of indirection that we're resolving here with the Binary Ninja Python API. So if I go back here, I'm just going to do kind of the same thing as the previous automation, but we're just going to do something a little bit simpler. So should we do get functions at or something? Get function at. I'm just going to do this by address. So I'm resolving this symbol and stuff. So get function at. Okay, so then we have our func, which is our dynamic function resolution code here. And then we'll just do like for instruction in func dot, it's just HLIL. So if we want to get the high-level intermediate language representation for this given function, I can just do func.hlil. And then for each of those instructions, we just want to check if there's a destination of a pointer. I think is probably the easiest thing to do. There's a bunch of globals that are reassigned, so we can fix those up by hand again, or we can just handle them properly. So for instruction in those, we want to do instruction or if instruction.dest is equal to is instance. And then we'll have the same thing again, if I can copy properly. Okay, so if it's an instance of that dereference, so basically all I'm looking for is these global pointer assignments throughout this entire function. So if it's of that type, then we want to do our renaming again. So rename, and then our address is going to be the instruction des.operands 0.address. And then this is going to be the instruction operands 1. So basically all I'm doing is I'm going to be accessing the parameters that are passed to this function. Have to get back to work. Great seeing you all. Take care, Kevin. Okay, and then literally all I want to do is get proc address call the operands to that. We'd probably just do tokens, or maybe we can do operands 1. Tokens is kind of cheating. I'm just going to do that because it's faster, because they're all going to be get proc address calls. So basically all I'm doing is accessing the tokens within this given call instruction in order to access the name of the variable. So it'll be like this, and then let's do some logging, and then we'll do instruction.operands, or sorry, this thing, and then this guy. Probably should have just assigned that to a variable because it's super long, but it's faster. Okay, and then let's comment that out for now, just because I want to make sure this is all working properly. Okay, so I think I just have to access each sub basic block. So for in BB, for instruction, I think. So I'll do that. So in Binary Ninja, it's pretty cool because even their like decompilation has basic blocks that you can access. So if I hit spacebar here from their high level intermediate language, then we can actually see there's these basic blocks like you would have in like their disassembly view, for example. So that's pretty neat. And it's really useful when you're doing things like fingerprinting for deobfuscation and stuff, which I've done, because it can keep things a lot more organized. So the reason that there's a whole bunch of basic blocks is because there's these if statements, and then I believe this would be a part of the same statement. Is that correct? Oh, the if leads to the basic block, etc. So now that we have the basic block, PKRW, thanks for the follow. For BB, okay. So we can probably protect against this by saying something like, so just to kind of explain what's going on, there's like some calls in here that will result in a global variable assignment that aren't our get proc address. So maybe I can just check for, let's just check that the token does have a get proc address in it. It's 1, and then operands tokens. I think it's just gonna be like 1 or something, or the 0. So dot tokens. It would help if I could code properly. High level if has no object dest. This is annoying. Maybe I can just try block this to handle the scenarios that we don't care about. I think that should work. Okay, maybe getting some other exceptions, but there should be. Okay, so we can just check if it's a high level assignment first. Y'all doing all right? Sorry, this will be done in like 2 seconds. Then we can actually look at the real functionality. We just want to get all this automation out of the way so then we can understand the binary better. Okay, that looks good. Oh, we also want, I think it's because it's, we need the text of it. Load library. So I'm just getting the text of those calls here. Call text. This is annoying. This is gonna be different. Yeah, let's do that. And then if it's low library, it's gonna be different. So call text, load library A. Vibe reversing? No. Real reversing today. Frackery. No more vibe stuff. I tried to do this with the LLM last time. It didn't work because it's too dumb. Oh darn. You only want vibe reversing? I like chaos. Yeah, this is going to be more orderly today. A little bit more. Tokens. LLMs still being dumb is a good thing. Yeah, definitely. For sure. Lopsec. Do y'all see where my mistake is? Call text, renaming, dest, else. Oh, elif. Come on. Print tokens. Okay, so then basically all this is going to do is rename what we want now. And then I'll just mark up the other ones by hand that are being assigned to the local variables, because those are going to be a pain with the automation. Load library, rename, .text. I messed stuff up for sure. All right, look at all those renames. Why didn't I actually do it? That's not the correct address, actually. Renaming, instruction operands, dest operands address. Let me double check this. Instruction, dest, operand 0, .constant. That's the, okay, I think that should be it. Cool. Okay, now let's just fix the small ones by hand that were not being assigned automatically. So this local variable is being reassigned, so I'm not going to rename it, but basically it's just reusing that local variable there. scanf, this is going to be cool. Okay, so those imports are resolved. Okay, so anybody have any questions? I know I was just kind of coding that away there, but basically all I was doing was trying to get all of these resolved, or all of these XORed strings into variable names. And then if we look here, if I click any of these globals now, I can see where they are used throughout the binary. The imports aren't a good example. So like this John Doe assignment, for example, it's being used in this function. So now I can see, okay, the string John Doe and HAL9TH are being passed to these other functions, and we're going to look at what those are doing. But let's start. Usually what I do when I'm reversing like a fairly complex piece of malware like this is I'll start from the beginning, just so we're not missing anything, and work my way down through the binary. And like always, in Binary Ninja, I have both the high-level intermediate language. I'll just make that pseudo C to make it make a little bit more sense to all of you who are used to reading C instead of their high-level intermediate language format, and the disassembly. So this is x86 portable executable, so it's Intel architecture. So that's what you can see in the instructions on the left-hand side here. And then the decompilation. So this is like a high-level representation in like a pseudo C syntax. So basically what I want to do now is, now that I've resolved all these imports and those strings, is I'll just work my way down from this start function, which is basically where the binary is going to begin execution on an actual Microsoft Windows system. So already there's this global variable that I'm not entirely sure what it's used for, but it could be an object or something. But let's just rename this to global. And then there's this arg1, which is being accessed at this second index here, which is the third offset of arg1, and that's being passed or assigned the result of this sub A31C0 call here. So, and then if we look here, it looks like this is the while arg1, and then the syntax looks kind of weird, but basically it's just accessing the next offset and then within a while loop, and then it's adding 1 to this result that is returned. So this is just like a built-in string length. So I'm just going to call it string length. And then if we go back here, we can see that string length is being called twice. So we'll just say arg1 length, and then this local variable is being used. And then basically the first is being checked against the second. And then if one is smaller than the other, then an assignment's made. While true sub, so var8 is greater than, so I think this might be a string in string, because basically it's getting the same index, and then we'll just say string1, and then it's getting each index and then seeing if they're not equal, then it breaks, and then if they are equal, then it keeps incrementing the index, and then there's a sub at the end with these two indices, or let's say string1 char. We don't really have to worry about this one too much, but I use duplicate. I want to do string2 char. Basically, we want to just make sure that we have some of these built-in functions marked up. I just don't know why it's subbing the first character from the second, and this is a D word on each iteration. So if we look at the disassembly here, it might be a little bit more clear. So it's iterating over each D word until it gets to a specific index in which they are not the same, and then it subs the two. So I don't know. Let's just say this is is that a string in string? It's used in a couple of places. Yeah, I would say that's the same. If not, string in string. This is like the dynamic function resolution that we looked at last time, that we just called get proc address. But okay, so that was in here. Okay, so this is setting up a bunch of structs. So we can probably, so global struct, and then in Binary Ninja, it's actually really useful. Here's the new struct one. So usually there's like auto struct usage creation. So that's what I was trying to do, but we can't do that in this case. But this would be a pointer instead. And this would be, let's just call this struct, uncstruct maybe. And then it's accessing the hex 10 offset of that struct, it looks like. And then getting the modulo D word. So if I go back to the C representation here, it is getting the mod hex 1000. I don't know what this is doing. It might become clear later on. Yeah, so I think this is just setting up global structs. And then there's some more setup here. So let me just show you what I did there because it's useful. So in Binja, if you like just hit S on these offsets, then you can create a struct. And then if you hit S again, then it'll just assign the if it is actually the struct member that's being accessed, or a direct access in this case, with it, which is just a char pointer plus 4 and then plus C plus 8, and you hit S, it'll actually create a struct member at each of those offsets, which is pretty nice. Again, we don't know what this is, so let's say arg2, argc, or arg1, 2. So this is probably the member of another struct that's initializing, and then the result of that is being assigned. Okay, so this is probably a pointer to the offset of 2 plus hex C. So arg1 is definitely another struct type, and then we can create a pointer to a pointer, and then clean that up a little bit. And we'll just say, again, we have really no idea what these are being initialized to. So maybe let's just leave them for now. We'll know that these field, or we can call this init unstruct to know that it's an initialized struct. And then the result being also struct1. So we have that assigned there. Now I don't know if in Binja this propagates upwards. Oh, it does. That's really nice. So because the return type was changed to struct1, then this value is now retyped to struct1. And then let's just say this is init bool. So it looks like that's probably some initialization variable. And it looks like this arg1, this wasn't retyped. So it'd be struct pointer. So if it's greater than whatever that accessed offset was, then it initializes this object, and then that's assigned as a global struct. So let's just say global struct1. And then this is going to be of type struct1. So again, we don't know what these are. We want this to be a pointer of struct1 because the first offset of struct1 is that bool. Again, we don't know what these are, but it's just useful to have some of these structs in place in case we see them being reused throughout the binary. Okay, so let's just call this global struct or something. This is gonna be global struct. Oh man, struct size or something. All right, let's instead of just marking up all these global structures, we could probably move on. Struct pointer. The 10th offset not defined in that struct type. So if I highlight this and go to types now, crap, I just lost my place. Struct pointer is a D word. So this first field is probably not correct because this is, if I show you in decimal, this is the 16th offset. So it being 4 bytes and that pointer being struct1, this doesn't make much sense, but okay, I'm getting lost in the weeds. So let's just call this like struct initialization. Unknown struct init, and then if we go back here again, we're going to have a whole bunch of different struct offsets where we get the string length and the unknown structure. Is this being used throughout? No, but it's being accessed with this weird hex 1000 thing, and then there's these globals. So I think there might be some global initialized structure to this 200,000 hex in size. But then it's being, so let's look at the code, or sorry, no, it's being divided by C. So that'll be, so for example, that'll be 512. I don't know why it's done that way, but size. And then this is probably other offsets. So this is dereferencing the D, right? And then the result is being assigned here. So is this like a pointer? I can't remember what struct2 is. Okay, it's just an empty struct that I created earlier. So what if we just call this a pointer to whatever this is, struct1? All right, that looks way better. Okay, so we have its size, we have its pointer, and then basically initializing that structure. Okay, and then this is gonna be struct1. Okay, and then this doesn't look like it's elsewhere, so I'm curious if we're gonna be able to determine if this global struct is used, but it's huge, so I'd be surprised if it would. Okay, so instead of continuing to mark up all these struct offsets in this current function, but the reason we kind of wanted to mark up at least some of it is because this is used in a bunch of spots. So, oh, and it looks like it's probably some string stuff. Imagine I'm pretty sure I'm just marking up like standard Microsoft stuff, which kind of sucks because it's called string struct init since it's not actually malware code. Because see, it's doing string copy A and string cat A. Then there's, so these functions were renamed based on built-in type information that Binary Ninja has. So I didn't rename these at all, but this is like concurrency stuff. So let's just call this MW string copy string cat. This is probably going to be used in a bunch of places. So it's basically initializing a global string structure and then copying a string into it. It looks like, I don't know why this is happening after. Oh, it's, I guess it would be always this case happening. Okay, so let's go back here. Yeah, so this is definitely string stuff. So maybe this is heap stuff. But as you can see here, there's these patterns. I believe this might be part of their command and control or their Stealer template stuff. Okay, so like see all these ones. So these are going to be accessed at various global offsets, but it doesn't really matter right now. but I think these will become important. Okay, so let's go back to our start function and let's continue looking at this functionality. We had those global struct offsets that were being initialized that are probably string related, probably Microsoft standard C++ stuff that we didn't really need to look at in depth, but still important to kind of mark up some structures. We have some synchronization. So create event A, I believe is related to threading. A named event object. Let's see. Yeah, it's for synchronization. And then there's these get calls. I think this is also exception pointer related, so probably don't have to worry about that too much. So get system time. Maybe this is logging related. Maybe this looks important because it's referencing our C2 stuff. So this is why we wanted to mark up those global variables as the strings, is so like we can just at a glance see like, okay, this is doing string copy A to this local variable with that name, and then it's appending SQLite 3.dll. So like we haven't reversed these C++ string functions, but we can kind of infer like, okay, they're doing string copy A with string cat, and then they're initializing that to a new structure. So we can just say like mw string cat new string, because it's creating a new string as well. And then the third parameter there is going to be the string to cat. And then this is probably going to be the original string. And then I don't know what this third argument would be. It looks like it's sync related. So maybe lock, global lock. Maybe not global lock because it's only being used in that particular instance for some reason, but I don't know. We don't have to worry about that too much. But what I try and do when I'm like looking at these complex functions is just basically try to infer as much as possible based on the code surrounding the functionality rather than trying to rigorously mark up all of these functions to the point of them being understood in their entirety, just simply because that can often take way too long. So, but obviously it's good to mark things up as you go as well. Okay, let's keep going. Okay, so let's get into some meat and potatoes of this malware. So Steac C is obviously a stealer. So if I go to Malpedia, what kind of software is the software that I'm using? This one, Xsnake. Hey, effing Mango, thanks for the follow. This is a reverse engineering software called Binary Ninja, and basically it allows you to look at binary formats and then mark up the database in order to understand it better, both the ones you're reversing to. Yeah, I'm using this program called Binary Ninja, and basically it just uses all these different algorithms to recover the bytecode that's stored in the file, and then also get a higher level representation of those byte instructions, the assembly instructions, back into kind of a pseudocode representation in order to understand them better. And then once that's done, you can like go through all the different functions in a given binary, for example, like this one, and then mark them up to represent what you believe the function is doing, essentially. So this is reverse engineering kind of at its finest. Basically, I'm just looking at some of these functions to get a good idea of what they're doing. And then the malware that we're reverse engineering is called Stealc C. So I'm just pulling up, this is kind of like the Wikipedia for malware. And basically it's an information stealer that's targeting a bunch of different applications. So hopefully that answers your question. Okay, so this looks like it's the main stealer function because we have these various string copy A's with these different copy operations, default 1001. And then, so we should probably look at these different string copy operations, but this is probably the main one that we want to look at here. Okay, yeah, so I think this is all related to logging, or at least the stealer functionality. So let's get, okay, but our global struct is used in here. So this is probably stringer. Let's just call this MW2. It's definitely copying some data. This looks like the communication function, but let me go back to that one that I said was probably the meat and potatoes here. This one. And I'm going to rename this to, I usually call them malware main. And this is called from our start function here. So this is going to be, so it's the malware that communicates via post requests with the server waiting for commands to be executed. I think it's just stealing stuff and then sending it to the server. Did you see a post request string there? Okay, this is being initialized to constructor iterator, vector constructor iterator, more C++ stuff. I thought, did you try to analyze the network data? Yeah, I think this does have sandbox detections. I'll check in 2 seconds. I haven't looked at the network stuff yet, but I was going to. So if you just hang tight, I'll take a look. Let me take a look at this. Sorry, yeah, let me double check. Instead of going through all these callbacks and stuff, I don't know what these these are probably constructors of something. And then these args are definitely other structs. I can't change those types. Why can't I automatically add those members? Okay, I could create these structs manually, but I'm surprised the auto generation isn't working. Okay. Same with this. Some sort of constructor. I'm glad there's some built-in stuff here. Okay. So yeah, so let me look at that. So, okay, so how these stealers usually work is they'll need like external dependencies. So here it looks like they're just downloading SQLite.dll, and then they'll write that to disk somewhere. What this default 100 is used for. So this is going to be then let's look at the cross references, and then we can figure out, like this is probably going to be a GET request, but we could still figure out the handler function for this. Pointer exception, where does it actually use that? Pointer exception get global. Maybe we want to, okay, multi-part form data. What is this? For some reason, our automation didn't mark these up, but now, okay, so this is going to be our, oh, did I not run the automation in this particular function? I don't think I did. Okay, let me do that instead of me just doing it manually. So this is why you want to write automation, so you can just run it all over the place instead of having it yourself. See, now they're all marked up for us. Okay, so if I go to the place where all of these are used, okay, so we have a lot of really good functions in here, but let me look at the C2 stuff like I promised, and then I'll take a look at the sandbox ones. I think this is on Unpack Me, so, but I can submit it to a sandbox if we want to look at it. Okay, so let me go to these guys. So these are like the Win INET APIs. So these are really commonly used by malware for HTTP communications. So if I look up here, there's send requests, and unfortunately these don't get marked up. So I'm gonna have to look up the parameters manually. And by markup automatically, I mean in like IDA, when it'll just resolve all the parameters for us. Okay, so this would be the header. Okay, so this is the content type header, and then the optional length, last optional arguments, and then, okay, so all that makes sense. Okay, open request. Yeah, it's through a post request. You're right. Xsnake. Cool. Okay, so yeah, pretty easy to like see at a glance what this is doing. This is our C2 function. I don't know what string this is. Oh, cool. Okay, so this is a good example. So see how this string is only 2 bytes, so it's 0D 0A, so it's the carriage return and then the new line return, or then the new line character. So in Binja, I can just hit Y on this global and then just make this a char array of 4 characters. I guess 3. We could just do 4. It has 2 null bytes, so we could just do that. And then we could see here that is that string. And then if I look in the disassembly, then we can see that this is /r/n. So the carriage return a new line. So this is going to be our HTTP request. Again, we want these to be characters. Look at this. Okay. And then things are starting to take shape here. So if I know it's not actual malware functionality, and I know it's probably like C++ related, I'll just add like CPP string cat new string instead. And then we can check if this has sandbox detections. Like this already has detections. So it's okay. And it has a full extract config. So this decrypted those XOR strings for us as well. But if I look at the Yara as well, I think it probably hit on some Yara stuff. Yeah, Felix's signature. So yeah, I'm sure like in any commercial sandbox, it would probably hit like a whole bunch of indicators. But oh yeah, nice. Steac C, I agree. A robot, motorcycles. Oh, he's doing captchas. All right. Yeah, sweet, that worked. And then Windows 10. So let's see how that looks. Meta Defender. Okay, our sandbox run is running currently. Thanks for the suggestion. Main account sub. Okay, so let's continue with some of these markups. So there's noise. And then this is like an alphabet that they're probably using for something. And then this is going to be system time. So LP system time. And then is that what members being at? Are they using this variable? Kumeda, thanks for the follow. I don't know what this is. This a key encoding algorithm? Weird. Not sure what this is. Okay, that looks fine. I think it's just all C++ stuff. It's probably used for some sort of encoding. Yeah. Okay, this is setting up the headers. Okay, let's see if the sandbox run is done. Yeah, so it does have a bunch of, or it has 2 detections in hybrid analysis. Found FTP location strings, and then their ML worked on it. So not a ton, but Okay, so then the internet connection's made, more new lines. We have hardware ID. So I'm assuming this is going to be initialized somewhere. Just the hardware. Is this more characters? There's a lot of these. I wish Benjo would just handle the 4-byte strings. Okay, and then these are kind of weird, but these are just new lines and then characters. And then HTTP send request. We have internet read file. So this is probably going to be different. So the second is the one I'm interested in because it's the buffer. And this is going to be the length, I think. And then this is going to be bytes read. And then we have string copy function. Okay, so this is all just basically C2 functionality, but I wanted to see if this is used other functions. Yeah, it is. So this is going to be a post. Oh, these functions are ugly. Okay, internet crack URL. That's good. This will be the URL. I think there's another string length. Yes. And this will be destination. Yo, what are you doing? I'm just currently looking at a piece of Stealer malware, and these are the network communications that it's making. And I'm doing this with this program called Binary Ninja, which will basically give me the machine instructions for this piece of malware and then a high-level representation in this pseudocode format that I'm marking up in order to understand it better. But basically looking at a piece of malware that steals information from computers. Yeah, so this does the post with all that data and then reads the file. So let's just say, and then let's see if the other ones look different. Okay, so internet open A, do the agent. What does this return? Internet handle. Have that struct in here. So sometimes Binary Ninja doesn't have built-in types. So that's all I was checking for there. So internet open URL A. We have the URL, which I don't quite see where that's coming. Let's see. Let's look at the disassemble. So that'll be internet open URL. The second parameter is this guy. What? No, that'll be the internet handle. But it's being set as the second argument. Weird. Push. And this is after an A. So that'll be the, and then so we'll do memcopy and then just MW. And does this have the, yeah, it's just using the handle that was opened. That looks wrong. Okay, whatever. I won't fixate on the parameters being wrong too much. But like this should have for sure. I think it's just this check stack. So let me do this. So I don't know if this is a bug or by design on Binary Ninja, but this check stack basically makes a whole bunch of room on the stack. So if I do set stack adjustment and then this value, then that should help with the arguments. Okay, so we have, this is like pretty crazy. Okay, so we have 3 separate URLs being constructed, maybe 2 separate URLs being constructed. One is the command and control address, which is this one, and then one's that SQLite address. So let's, I want to see if I can find where the SQLite address is actually used. I think this get is, yeah, there isn't a direct reference to it in this function, which is annoying. Okay, we can mark up some of this stuff. So this will be the results. So get Windows directory 104. I don't know what that is for. Get Windows directory. I don't know what the directory it's getting is. Okay, that's not specifying. That's specifying the max size. So that was, the constant was right. I think max zone path is right. And then LP buffer is going to be the. This is just the C Windows drive path, I believe. Yeah, C:\Windows. So we'll just say Winder, and then we're just getting the volume information from there. This is probably making the. So usually they use this serial information for a unique identifier for the given system. So that's probably what it's doing. Get volume information A, and then what's the third parameter here, or fourth parameter? Yeah, LP volume serial. And then there's probably C++ stuff. I don't know. Oh, okay, so no, I think this is a custom algorithm probably. Multiplying by this number, nonsensical, also nonsensical, but actually maybe let's Google these because maybe they are sensical. Okay, so we Googled that constant, and then basically it's their hashing algorithm according to this eCentire IOC's thing. So let's add this to our notes. What's the date? The 15th. Okay, so what do we do today? I'll just eCentire IOC information, and then okay, so this would be the hash serial, and then that's called 3 times, 4 times, a whole bunch of times, and then formatted into this string. So let's get volume serial, and then we have, okay, these offsets look messed up because we have get volume serial, and the results are going to be an EAX, and this is not reused elsewhere. So The calling convention might be messed up here. Sub ESP. So what calling convention is this currently set to? C decal. C declaration cleans up the stack, I believe. Calling function pops the arguments from the stack. Okay, so why am I not seeing where this is used though? Maybe it's because this add that's messing things up. I don't know what this is doing. Is this just a copy? But like a whole bunch of instructions, probably C++. But hey, how doing? I think I'm probably gonna wrap things up pretty shortly here, just because I got to make some dinner. But really appreciate y'all hanging out with me while I work through all this gross C++ code. I think we should be able to get through most of it or the rest of it. Yeah, it looks like these are actually interesting functions after this. So there's multiple command and control functions. It has the ability to get files and write them to disk. Okay, so what I'm gonna do is just kind of save what I wrote in the notes. So this is gonna be our new version, XOR with globals with global renaming. And then we're also going to have this global naming reassignment for the resolution functions, which turned out to be really useful. And then let's attach the hybrid analysis run that we did as well, just for, brevity. Okay, so that's kind of it for the notes. So for those of you who are not aware, we do malware analysis training. So that's what lets me do all this free content and these streams and show you all how to do a lot of this stuff. So I just want to plug that. So invokere.com is the company that I run, and we do malware analysis training. So if you need help with any of those things, definitely check us out. I'll probably be able to stream again next Tuesday. I'm going to try and stick to a schedule so it's more predictable. And I'm just going to throw the Discord in the chat in case anybody wants to join. So 2 seconds. I should definitely have the link just handy. So yeah, I'll throw this in the chat if y'all want to join the Discord and hang out. Yeah, if you want to know how to mark up these structs and analyze malware in general, we have a whole binary ninja course. And then if y'all need help with anything else, feel free to ping me or on our socials or whatever. They're all available on the website. So we'll see y'all next Tuesday. Feel free to ping me on any of those platforms. So take care, y'all.